So 3, 2, 1. So titration is basically the process of finding out what is the concentration of a given solution based on a chemical reaction between two different things. Basically, you want to find the amount of something present in something else. And we use a reaction between multiple solutions to find this out. So before you begin your titration experiment, you always want to have the proper PPE. So that's a mask and gloves, tying your hair back, maybe pulling your sleeves up, or being properly covered. It really depends on what you're working with. In my case, I'm working with food coloring and water, so I don't necessarily need PPE for this experiment, and I'm not going to use a mask because, again, I'm working with water. So basically, titration works off this idea of stoichiometry and really fundamentally the laws of conservation of matter, which is where reactants and products react in an equation to come to an equilibrium. That's kind of what we're interested in. So usually you would have something that you don't know the concentration of. In this case, we're going to say kind of pretty much red water, and we don't know the concentration of a given given thing inside this water, basically like a given species in this water. But we know that it's soluble. So we have something else, which is our titrant of a known concentration and a known volume, of course. And we're going to imagine that this is a burette. So it's going to be counting down to lower numbers so that we can calculate the difference in the end. This makes it really easy for high precision calculations because, as we can see, this burette is very precise with its measurements. Now, telling when a titration is done is when it comes to an equilibrium. There are a few ways to do this. We can use conductivity titrations where a precipitate is formed, and when the precipitate is fully formed is when the reaction has come to its equilibrium. And when it's done, we can measure this with a conductivity meter. Or we can use acid-base neutralization reactions when there'll be a clear end to it. So in the case of our analyte in our titrant here, if we pour them into one together, a new color should form. As you can see, it looks like it's come to its equilibrium as purple has formed, and there's still some titrant left. As you notice, I also used a small amount of titrant because I didn't want to take the entire thing out of the bottle. So here's our equilibrium. Again, when going about this, we might want to run multiple tests to make sure that our accuracy is ensured, and actually do this multiple times with finer amounts to say, oh, well, if it took around 2 milliliters, maybe we should do 0.1 milliliter increments at our equilibrium. The last thing to note here is that titration is actually really important when it comes to things like analyzing nutrients inside foods or analyzing the amount of contents inside blood, like maybe you have low iron or low cholesterol, and a doctor would go through and do blood sampling to actually titrate and see what levels of these given chemicals are inside your blood or inside given foods.